Hello guys, and welcome to a video on differentiation. So, what differentiation is finding the gradient of a curve. And then you can find gradients of tangents and gradients of normals of a curve at a specific point. We'll follow integration very soon, but we just got to get the simple bit of differentiation out the way first. And I'll show you how to do it by first principles. So you make sure, so you actually know that the derivative of this is from this, if that makes any sense at all. So I'm going to show you some notation at the moment. So if y as a function equals x to the power of n, then dy by dx, the derivative of y with respect to x, equals, so what happens is you bring down the power, so it's nx, and then you subtract the power by 1. So it becomes nx to the power of n minus 1. So let's do it another way. So if f of x, if a function of x equals a x to the power of n, where a is a constant, x is a variable, and n's also a constant as well, then f prime of x, or f dash of x, is equal, so you do exactly the same thing as you would here. You bring down the power times that constant together, so that makes a new constant. Two constants equals another constant. X is still a variable, so x remains just x, and then you subtract the power from 1. And that's literally what differentiation is amongst polynomials. It's very simple, it's easy to do, and you'll get this straight away, I bet. All it is just finding the gradient, and that's it. So what I'll do, I'll just put up 4 examples of when there is a constant at the front of it and when there is not. Okay, so I have now 5 examples. I do apologize for the y equals 1 over x squared and that. It's just, I'm just stupid at times. But anyway, so how to differentiate x to the power of 6? It's very simple. Because now this is in the format of y equals x plus 6, where 6 is equal to n. So what we do, so the derivative of y with respect to x is equal to, so you bring down the power, so it's 6x, and then you subtract the original power by 1. So 6 minus 1 is just 5. And that's all it is. So dy by dx is equal to 6x to the power of 5. That's it. Okay, so moving on to example B, y equals 1 over x squared. Okay, x squared is not in the format of this or this. There's no constant at the front of it, so what are we going to do? Okay, what we are going to do is we're going to use the reciprocal. So 1 over x squared, I'm going to assume that you already know about laws of indices and pretty much from GCSE. So if you don't know, please go watch a video about how to use the laws of indices and then come back to this, because using the laws of indices is so important. It's ridiculous how much is used in this topic. So x to the power of minus 2, so you're just flipping it essentially. So then the derivative of y with respect to x is equal to, so you bring down the power, so minus 2, yes, you even take the minus 2 down because it's also an integer, x to the power of minus 3, because minus 2 minus 1 equals 3, following this rule. Does that make sense? Okay, brilliant. So now we're going to move on to a constant in front of the x cubed. So now what we're going to have is f of x equals 7x cubed. F prime of x, or f dash of x, is equal, so you bring down the power, so 3 times 7, we're going to put it in brackets just to make it easier for you, x to the power of 3 minus 1, which is 2. And then that will equal 21x x squared. Hopefully that will make things a lot easier. So now we're going to move on to f of x equals the square root of 36x cubed. How are we going to do that? Like, isn't this, you know, a square root? This is not in the format at all. So how the hell are we able to do this? It's relatively simple. Right, I'll tell you, so what is a half times x to the cubed? Following the laws of indices, you should be able to get an answer of 36x to the power of 3 over 2. If that makes sense. Okay, so what you do, f dash of x, or f prime of x is equal to 3 over 2 times 36. So you bring down the power and times it by the original constant. 36x to the power of 3 minus 2 minus 1, which is just a half. And then that should equal 54. So it's going to equal 54x to the half. Or, if you want to put it down fully simplified, 54 to the square root of x. And that's what the derivative of that equals to. Okay, now we're going to move on to something different now. So we're going to move on to y equals the square root of t. Now this is going to be slightly confusing because we've always been following y and dy by dx. So now we're just going to follow exactly the same format. So y equals t to the power of a half. T usually represents time a lot of the time. So dy by dt, so the derivative of y with respect to t is equal to a half t to the power of minus a half, which is then equal to 1 over the square root of t. And then that is the derivative of dy over dt. It's relatively simple. It's not a problem whatsoever. So I'm going to show you a few example questions that you can follow yourself, and then you can give it a go yourself. Pause the video, and then we'll move on to something with more functions in itself. Okay, so I have got some examples for you to do. Literally just pause the video right now and then see if you'll be able to do it. But before you just pause it, I'm just going to explain the extension question. So given that 2y minus x cubed equals 0 and y is greater than 0, find the derivative of y, 2y squared. Find the derivative of y with respect to x. So try rearranging unfamiliar unfamiliar equation like this into a form that you can recognize, and then you can actually differentiate yourself. All right, good luck with these questions, and then I'll reveal the answers right here for you when you've completed all of these. It's just a little exercise that you can do, and hopefully it will just help you advance along when we do more challenging stuff. So here are the answers, and hopefully you should have got most of these at least, or if not all of these. So now I'm going to show you on how to differentiate a quadratic or a function with 2 or more terms, and then I'll show you how to differentiate by first principles. So if we have, okay, here's an example. Find dy by dx if y equals to x cubed bracket 3x plus 1. You might think here, oh, this looks like something I can't do. But no, it's relatively easy to do. It's not a problem whatsoever if you just know what you're doing. So The first thing we're going to do is expand this. So what we're going to get, x cubed times 3x, we're going to get 3x to the power of 4 plus we times 3x cubed by 1 is just 3x cubed. So now, if we differentiate dy by dx, the derivative of y with respect to x. You're probably thinking, if you have no knowledge of differentiation, I think you wouldn't have a clue what to do here. But it's very, very simple just to do. All you have to do is treat the functions as if they are on their own. Like that, and like that. So what you do, you differentiate as normal the first function. So it's going to be 12x cubed. So bring down the power, subtract the power by -1, plus x cubed. So you bring down the power times x, and then subtract the power by 1. And that's it. That is literally differentiation in a nutshell. I mean, if you want to simplify it, then be my guest. X squared 12x plus 3. It's honestly much simpler than people perceive it to be. This is a full-on quadratic or cubic. No, sorry, quartic. And you can find the gradient by just simple differentiation. It's not hard. So essentially the rule of thumb is one at a time. So you differentiate one function, then you differentiate the other function. Let me just show you another example so you just wouldn't end up confused. So if y equals x to the power of -2 over x squared, find dy by dx. That one's really simple. That one's pretty simple to do. All you have to do is split, so x over x squared minus 2 over x squared. This will give 1 over x minus 2 to the power of x to the -2. And that's all it is, which is equal to x to the power of -1 minus 2x to the -2. So you don't have to, once you get used to it, you won't do the amount of lines I'm currently doing here. I'm only just showing you because it's step by step by step, so you can fully understand what I am trying to do here. So dy by dx, you do the same as normal. We're going to do it one at a time. So differentiate x to the power of -1. -1 x, we're going to just put the 1 there, just so you know. -1 minus 1, which is -2. And that's all it is. That's fairly simple. Now, we've got something interesting here. So we've got a minus sign with the function, and then there's also another minus sign. Obviously, people who do mathematics should know that 2 negatives makes a positive. So that's what we're going to do here. So we're going to bring down the power, which is going to keep that minus there, bracket, minus, so we know, because we're bringing down that -2, we're just going to keep it in this bracket. 2 times 2 is 4, obviously, x to the power of -3. And then if you simplify that, this will give minus x to the power of -2 plus 4x to the power of -3. And then that's it. That is really, really simple to do. And if you really want to simplify it that much more, 4 over x cubed plus, minus x over, 1 over x squared. That's it. That's really, really simple to do. So I'm going to give you some exercises to do, and then we're going to move on to first principles, which is how the f do you get from this how do you get from a function of y into dy into dx? That's what we're going to do for first principles. It's not difficult, it's just tedious, and it's doing the same thing over and over and over again. We're only going to do it with polynomials, so we're not going to do it with sine and cos. That's a lesson for next time. Okay, here are just 4 examples and maybe an extension if you're able to be confident enough to do this question. I'm going to do this question anyway, only because it's something that, you know, not many people can. That's where differentiation starts to get interesting. It's where, because differentiation is the gradient of a curve, we're going to find the gradient of the curve at that certain point. So here is a quarter. X is a quarter and 2 is y, and f of x is this function here. So when we get back, I'll do this question and then I'll reveal the answers for these 4. Okay, here are the answers for 1, 2, 3, and 4. So the answer for number 1, so 2x. I should mention as well, so if I just do this a second. So 2x squared turns into 4x. Minus 6, the x drops off because 6 is just 6x to the power of 1. 6x is just equal to the 6x plus to the power of 1. Sorry, I got muddled up there. And the minus 3 just is got rid of because 3 only has a horizontal gradient, and when you differentiate a constant, it's just 0. That's it. That's all probably you get confused by, but it's no problem at all. You'll get used to it as we go along. And then here are some of the other answers as well. So 3x. So you expand and then you differentiate for the answer. And then here you have to split it off into 2 fractions using the law of indices, and then you get your derivative. That's it. Blah, 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 blah. Sorted. Okay. So the extension question. Find the gradient of the curve at the point a quarter and 2, and f of x is equal to 1 over root x. So we're going to start off with f of x equals 1 over x to the half. That you can just automatically change it. It's not a problem at all. So x to the half, when you flip the reciprocal, will turn to x equals minus a half. Yep, you got it? Okay, so we're going to differentiate now. So f of x is equal to minus a half x to the power of minus 3 over 2. That's a 3, by the way. I didn't mean to, not a b. So anyway, and now you differentiate it. Now what do I do? So we find the gradient of the curve at the point a quarter 2. The 2 we can genuinely get rid of. It's no point having it there. Okay, so we're going to replace a quarter. So we're going to put in a quarter here. So a quarter is now our x function. So now we're going to plot that in. So bracket. So minus a half times a quarter to the power of minus 3 over 2. And that gives an answer of, okay, the answer is minus 4. And that is the gradient at that point. The y completely doesn't matter because that's where the point a quarter is. What matters is the x function, not the y function. Okay, so now what we're going to do, we're going to move on to first principles. Why do we get from a quarter x to minus half x to the power of minus 3 over 2? And that is what I'll show you next.